Nick is working at the NS, the Dutch Railways. He has a master in cognitive science from the University of Amsterdam, and also a master's in computer science and in philosophy of science, technology, and society from the University of Twente, and a PhD in psychology from Bangor University. And then did a postdoc in cognitive neuroscience at the University of Trento, at Dartmouth College, and at Harvard. And at NS, he's currently working in the field of prognostics and health management. And he's talking about detecting HVAC cooling malfunctions in trains. So Nick, the screen is yours.
Okay, thank you. Sorry, I'm muted. Can someone unmute me?
No, I hear you. I think we hear you and we can see your screen.
Okay, excellent, great, thank you. Yeah, so I do see myself in the bottom of the screen.
Yeah, that should be no problem.
You have to live with that. It's irritating, I know, but you have to.
Okay, I hope it's better now. Thank you very much for the invitation. Yeah, I will give a talk about HVAC cooling malfunctions in trains. With HVAC, I mean the heating, ventilation, and air conditioning systems that we use in the trains at Dutch railways. I will give a brief overview of the real-time monitoring that we have active in some of our trains. Then discuss how we can detect malfunctioning HVAC units, either based on visual inspection of temperature plots, or what we can do using diagnostic codes that are given by these HVAC units. And I will conclude with discussing the future work. NS, or Dutch Railways, is the major passenger train operating company in the Netherlands. I'm showing a few numbers here pre-COVID, with more than 1 million train journeys every day. Lots of passengers, lots of colleagues on a very busy rail network. Unfortunately, due to COVID, well, COVID of course has caused a lot of deaths and people getting very sick. It also means that at this moment for Dutch Railways that we transport a lot less passengers than usual. Nevertheless, we do have our challenges in the summer, and that does not only involve our HVAC units, it's also sometimes difficulties with traction, for example. But still, HVAC units not cooling well in the summer is an issue that we are experiencing. And this is not good for our customer satisfaction, because passengers don't like to sit in hot trains during hot weather. And that's why we spend considerable resources on trying to make sure that our HVACs are working as well as possible also during summer. I'm not talking about the winter. Of course, the HVACs are also important in the winter to make sure that the trains are warm enough, but we tend to have less issues with the heating part. I'll give you a few numbers here, or illustrations of why this is important. We see that in the summer, the service requests related to HVACs are really high in the summer months. So on the plot on the left top, indicated by A, you can see the number. You can see the service requests, and at the bottom, at the horizontal axis, the month. And around June, July, August, the service requests are much higher than in the other months. And in the bottom plot, unfortunately, my screen is a little bit obscuring the numbers. Let me see if I can move it. We see that the number of service requests as a function of temperature. And at the right-hand side, we talk about temperatures higher than 26 degrees Celsius, the numbers of service requests is really much higher than during the cooler periods. And that's indicating that these HVACs really seem to struggle more with high atmospheric or outside temperatures. I'm trying now to go to the next slides. This slide illustrates briefly the real-time monitoring system that we are using in our trains and also part of infrastructure, but the focus is here on trains. On the left-hand side, we see different train series, and these send wirelessly data to our data center. And this data involves both sensor readings, so for example, voltages in the traction units, but also temperature data from HVAC units. And it also involves diagnostic codes that can be given by the different subsystems that are active in the train. This data is both used in real-time monitoring operations. That's on the right top part. That is used for troubleshooting when a train has problems and right at that moment needs support from the help desk, and the help desk can then remotely see some condition parameters of the train and in that way guide drivers to help to solve the issue. It's also stored in our big data environment where we can do longer term trend analysis, and we call that RTM analytics. And it's this part that I'll be talking about where we do analysis on the data from the trains. Why do we want to use this real-time monitoring data? Well, it could help us in improving fault tree analysis. Together with expert knowledge about HVAC systems, it would allow us to come up with a good fault tree that can help us in detecting failures and also diagnosing exactly where the problem is so that we can more directly guide a mechanic in solving the problem, or even also help in detecting an imminent failure or seeing that something in the future is likely going to break. And the diagnostic codes can be a source there, in addition to the temperature readings. The temperature readings can indicate that it's getting too hot in the coach, and that may indicate that the HVAC is not cooling when it should be cooling. The diagnostic codes have the potential to be more precise in which subsystem of the HVAC there is an issue, and in that way provide the better guidance for the repair. The first strategy is to use temperature sensor readings. And just to give an example what this data kind of looks like, I'm showing here a 4-coach train set. Of this type, we have both train sets with 4 or with 6 coaches. And these train sets come with 2 HVACs per coach, 1 on each coach end. And because they are double-decker trains, we have sensors at both the top and the bottom level. So that means we get 4 temperature values for each coach. And in addition to those, we have temperature readings in the cabins. The cabin is where the driver is located. And of course, also the driver would like to sit in a well-cooled train when it's hot outside. One kind of simple but also robust approach to see if an HVAC may be malfunctioning is to look at the fleet level. What is the median temperature? This is a robust estimate of what we would assume is normal behavior, assuming that most HVACs are working, and then see if there are any HVACs where we see a significant deviation from this computed median. And this could also help, for example, if it's a bit warmer at some point, then the coach temperature may increase a little bit, but that will happen in all the coaches. And then still a deviation from the median is a good way we feel, to find deviating HVAC units. To give an idea how this looks like, I'm showing here a temperature plot, a heat map, with on the horizontal axis different dates. So each column corresponds to 1 day. And on the vertical axis, the different temperature sensors. So starting with the cabin temperature, and then we have 4 temperature readings for each coach. This is a 6-coach train set. And at the very bottom, we also show the outside atmospheric temperature. And this was during a warmer period. And what we see is that in the 4th coach, the top 2 rows, we see high temperature deviations, indicating it's warmer in that coach than in the other coaches. And this is on one coach end, because this is the upper and the lower level on one coach end. We also see in the row below somewhat colder temperatures, and that is from the other HVAC units in the same coach on the other coach end. And this is actually indicating that the other HVAC has to work harder in order to keep the temperature in the coach at acceptable levels. So in short, such heat maps can help us in identifying malfunctioning units, even if this is not observed or reported by the personnel on the trains. A second approach that we have looked at is using diagnostic codes, and this is visualized on the right-hand side. These diagnostic codes are provided by the manufacturer of the HVAC unit and are then sent to the central computer and then wirelessly to the data center. And these give more specific information about certain subcomponents that may not be functioning well. And potentially these can be used for better fault tree analysis. And for example, Marielle Stoelingra's group, they have lots of experience with those and they can do very clever things with them. And what we wanted to see if, which codes can we really use to see if there is indeed functional failure happening in HVAC units. For this, we collaborated with Carlos Badde, who is also one of the organizers here, and Duncan Janssen from the University of Twente. And what they did was they first started making a big label data set using the temperature readings that I showed earlier in strategy 1 of my talk, where they did some manual labeling on a subset of the data, indicating whether they thought the HVAC units were defective or not during a particular time period, and they found good inter-rater agreements. They then defined a couple of features, including deviation from the set points or whether temperatures deviated from other units, so similar to what I showed earlier with the deviation from the median. And then trained a classifier on the subset of the data and used it to predict malfunctioning using the remainder, the largest part of the data, so that in the end we get a very big data set with labels indicating during which period the HVACs were not cooling well or were cooling well. Then they used this labeled data set to see which of the diagnostic codes could be used to predict failure of the HVAC unit. So here we look at, even though the data set is already labeled on the temperature data, here we are interested in which information does the diagnostic code give us. And they tried a lot different approaches and were quite thorough, but the results were not that convincing, in the sense that these diagnostic codes could be used at this fleet level to really detect the malfunctioning using the diagnostic codes. And why is that? Well, what probably doesn't help here is that there are a lot of different codes, and there are not so many cases of malfunctioning HVAC units. And that is, of course, good news for passengers because they don't like to sit in hot trains. But for training and testing a model with these diagnostic codes, it is less ideal. And briefly, it was summarized in that the good thing was that in 97% of the healthy periods, there were no diagnostic codes present. But also in the unhealthy periods, so when suspected malfunctioning, there were also no diagnostic codes present. And they observed that only few diagnostic codes seem to be really related to functional failure of not cooling well. For the last part, I will mention something at how these heat maps are currently used at Dutch railways. Currently, we send automatically a weekly report with both the temperature heat maps and the diagnostic codes to the maintenance shops. And then if a train is coming in for maintenance, these can be used to see if there are malfunctioning HVAC units and then be subjected to repair by the mechanics there. And we recently discussed how well this is working, and I got positive responses from the maintenance shops. They said that these heat maps really help in finding the defective units so that they can spend more time on the units that need more attention and less time on the units that need less attention. And also they found that actually these diagnostic codes do really help in repairing these units. I have to say that there is a bit of a capacity problem sometimes. So sometimes there is not enough time available to repair every unit that they see as potentially faulty. That has to do with sometimes there's a peak demand and then there's not enough mechanic capacity available. And that is also challenging for our yearly maintenance. So every year there's a more thorough preventative maintenance on the HVAC units. And at the moment, it's just difficult in the scheduling and in the logistics to find the mechanic capacity to direct them to work on the problematic looking HVACs. From the maintenance shops, I give a few examples here of what I got back in how these heat maps and diagnostic codes have helped them in repairing HVAC units. Something with the PLC outputs, sensor deviations, defect condenser fan, defective solenoids, and a case where they were able to see whether a high temperature was due to the startup phase of the train set or whether it was a more consistent problem that occurred during service. So the bottom line is that even though in the previous analysis it was hard to, at the fleet level, to really detect failure using the diagnostic codes, we do hear that for troubleshooting individual HVAC units, these codes can actually be useful. At least, maybe not completely identifying what exactly is wrong, but at least in making it easier to find exactly which part may be wrong, may be malfunctioning, or which not. In the future, we're planning to even further automate HVAC alarm system for maintenance shops, so that there is less visual inspection necessary to identify problematic units in collaboration with the University of Twente. And we will look more in detail about how this information can be used for more dynamic maintenance strategy. So for example, when a heat wave is forecast, that maybe some problematic train sets can already early be taken out of service, so that when there's actually a heat wave, the peak on repair demand is reduced. This is, however, quite logistically challenging, so it's it's a nice problem to work on, I think. And this is together with University of Eindhoven as part of the Primavera project. And with that, I would like to thank you for your attention. I would like to thank Carlos and Duncan for their work on the diagnostic codes, and my colleague at Dutch Railways, Inka, Bob, Jans, Anke, and Roel. And if you have any questions, please feel free to contact me or my colleague Inka. That's it. Thank you for your attention.